next biggest agency? That's NIH. Remember I told you Health and Human Services, NIH, CDC, FDA. $700 million. It is the big investigator-initiated, come one, come all, 7-Eleven of SBIR agencies, to summarize what I said this morning. NIH is a complicated agency. In some ways, I think they're more complicated than the Department of Defense. Department of Defense is large and it's got different components, but they kind of put stuff out there and say, here, can you do this? If so, respond. You got one person to work with. NIH is a real conglomeration. It actually is an umbrella agency over 27 institutes and centers, each with their own budgets, each with their own congressional charters. This is a matrix of what they look like. You've got institutes within NIH that I like to kind of position them in 4 different buckets, 4 different categories. You've got your disease-focused institutes, like the National Cancer Institute. You've got your body part institutes, like the National Eye Institute. You've got your tools institutes, like the National Institute of Biomedical Imaging or Bioengineering. And you've got your life stage or lifestyle institutes, like the National Institutes of Aging or the National Institutes of Alcoholism and Alcohol Abuse. And it's like a big, messy Venn diagram with the areas of interest of these institutes and centers overlapping one another. And they use their SBIR monies in one of 2 ways. They take the majority of it and they put it out in something called the omnibus solicitation for SBIR and STTR. There's nothing else out there like that as far as an SBIR solicitation is concerned. It's probably 85 to 90% of their money. All 24 of the 27 institutes and centers that award grants participate, plus CDC, FDA, and the Agency for Children and Families, all participate. And whose ideas do they fund? Yours. If you've got something, if he thinks he can make antennas that'll help people, I don't know, do some, that'll cure some disease, an implantable 3-dimensional printed antenna that he can put in some medical device, James can apply to NIH anytime he wants, okay, through this omnibus solicitation. They then have special solicitations that they will develop specific to interests that are narrower to a subset of the institutes, okay? But it's the only agency where you can essentially apply with what you want to do whenever you're ready. You do need to understand how they're structured and how they work. So the NIH homepage has something called Grants and Funding. If you click on this, it takes you to the Office of Extramural Research. That's the office that's responsible for all of NIH's extramural research. What does NIH want? Anything that you think will improve human health. Okay? So is the gist of it. Their phase 1s are typically 6 to 12 months. Their guideline is $150,000. Their phase 2 guideline is typically 2 years and $1 million. Up until this year, NIH has made really large awards. I have to completely rethink what I've been doing. My team at BBC has to completely re-engineer how we work with our clients on budgets from what we've done for the past 10 years. Because NIH was the only agency where you could build your budget from the bottom up, and if you needed to have $200,000 for direct costs, you could add 40% on top of that for indirects and 7% on top of that for fee and end up with close to a $300,000 phase 1 budget, no worries. They are now subject to the congressional caps, so $225 for a phase 1, $1.5 million for a phase 2. Are any of you working on products that are going to require FDA approval in here? Okay, so here's the other cool thing that NIH has. I think they're going to have to scale back the amount, but they have something called phase 2 competing renewals for projects that need FDA approval and a few others, but it's mostly focused on technologies that require FDA approval. Once you get a phase 2, you can ask for up to 3 years, and it has been up to $3 million. I think it's going to get scaled back to an additional $1.5 million to continue your work towards getting FDA approval. So you can start to get some substantive money between a phase 1, a phase 2, and a phase 2 competing renewal. Okay? And then phase 3 is commercialization. You figure out how to do it. You figure out where you're going to get the resources. Okay? NIH has probably the most robust search engine and tool set of any of the agencies. It gets a little frustrating sometimes to search DoD and NSF for information, although it's there. At NIH, it's frustrating because the user interface isn't good, but the amount of data when you can find it is really robust. Okay? So here's just an example. for those of you who like statistics. And I made the comment earlier, I don't know if any of you caught it, about how NIH up until the last few years was funding things at a higher percentage than any of the other agencies. What you see here, the blue lines are the number of applications that NIH received. These are SBIR phase ones. The green lines are the number they funded, and the red line is the success rate. Pay attention to the Get Connected. NIH has a number, they're tweeting, they're blogging, they're RSS feeding, they're newslettering. They've got all kinds of information that they're pushing out to try and get more people engaged with them earlier in the process. And then the SBIR homepage looks like this. It's actually updated on quite a regular basis. If you guys look on the right-hand side, you remember when I told you that every agency has to put a link on for fraud, waste, and abuse? So you can see where NIH is right there. There's the omnibus solicitation. There's the SBIR, there's the STTR. You pick which mechanism is better for you. And then here's a document, it's called the Research Topics and Program Descriptions. This lists all 24 institutes and centers plus CDC, FDA, ACF, who the primary SBIR contact person is, and what scientific, technical, clinical areas they're interested in. This is not a detailed topic list, even though it's several hundred pages long. This is a general description of the areas of interest, okay? How your proposal gets processed through NIH to the institutes and centers is something that takes a couple of hours, so that's part of a more extended NIH training. But that's a particularly important document for you to be aware of. The omnibus solicitation has 3 deadlines a year: April, August, December. Those are essentially review cycles. They use external peer review. They convene SBIR review panels, many of them with hundreds and hundreds of reviewers for each cycle. The deadlines are the 5th of the month, but I implore you to never push the button past the 1st of the month, okay? For those of you who will be applying to the August deadline, the study section, the review group, will meet and grade your paper in the October-November timeframe. And you heard one of the presenters talk about how you're going to get bullets of strengths and weaknesses. You get something called a summary statement, a summary of review. It'll have the 5 review criteria: significance, investigators, innovation, approach, environment, each scored for your edification, and then it will have this impact score. You will get that information somewhere just after November, after your study section meets. But by law, NIH's peer review process has to have 2 stages. The second stage is internal to NIH with the program directors who hopefully you've reached out to and talked to, just like you did with NSF. And they're going to discuss in the January-February timeframe which proposals they want to fund, and they'll make their funding decisions in an ideal world in the March timeframe. So this is what NIH's timetable looks like. Okay? This is what an NIH proposal looks like. Compare this to what I showed you for NSF. The issue with NIH, way more money than NSF, much more flexibility, very hard if you've never written an NIH proposal to decipher what goes where. You have information here. This stuff up here is essentially your research strategy, okay? You've got 1 page for an executive summary and 6 pages for a phase 1, 12 pages for a phase 2 for your research strategy. And by the way, do you see the word commercialization in there anywhere? What do you think happens if you don't put some commercialization information in there? Not good. But it's not intuitive when you look at that, where that information goes. So that research strategy has 3 subsections: significance, innovation, approach. We're talking significant science, significant problem in the market, significant commercial opportunity. Okay, all has to be addressed in there. You then have a bunch of information, if relevant to you, on human subject or vertebrate animals, which tends to be much more common in NIH proposals than for other agencies. But you also have biographical sketches for your key persons. You have facilities and other resources. You have budget and budget justifications. You have commercialization plan for phase 2s and fast tracks only. So there's a whole mess here of stuff that gets put together. There's nothing here that's different than what goes into an NSF or a DoD proposal, but what it's called, what terminology and language you use. One agency has objective or goal, another agency has hypothesis to prove, right? One agency has milestones or deliverables, another agency has aims or specific aims. They're the same things, they're using different terminology based on the culture and the way that agency works, okay? A 12-page commercialization plan for a phase 2 at NIH looks a lot like a 12-page commercialization plan for NSF phase 2. It's got 7 sections in it at NIH, an executive summary, information on the company. So by the time you get to a phase 2, there's a whole lot more information on the company. Market, customer, competition, so that's our qualitative and quantitative description of the problem. Intellectual property, you have had a lot of questions today about IP. There's a whole section in a commercialization plan. How you're going to raise additional money, which we call finance plan. How you're going to operate your business or production and marketing plan. And how you're going to generate revenue, when you're going to generate revenue, how much revenue you're going to generate. Now, you might be all excited and say, well, woohoo, that's not till a phase 2. Is anyone in here writing a phase 2? If you can't sit down and frame out that commercialization plan now before you ever start to write your phase 1, you don't know enough about your project and the ultimate goal, which is commercialization, to even write your phase 1. So a lot of people get lulled into false security thinking we don't need a commercialization plan until phase 2. All we need to put is our technical feasibility in phase 1. And that couldn't be further from the truth. So I encourage you, whatever agency you're looking at, to do commercial feasibility first. And then when you determine that commercialization is feasible, then you start to look at your science and technology. NIH uses external peer review. The Center for Scientific Review at NIH convenes study sections and recruits reviewers. And by the way, I have a piece of advice for you. How many of you have specialized or unique expertise in some scientific or technical area? Yeah. How many of you have been reviewers for NIH or NSF? Guess what? Thank you. Guess what the rest of you can do? Volunteer. You get paid a little bit, right? Not a whole lot, but you get paid a little bit. Very, very interesting way to see what comes into those agencies. If you have some type of unique scientific, technical, or commercial expertise, is to volunteer to be a reviewer for NIH and NSF SBIers. So as an aside, that's something you can do. And as an example, what did Jesus say his area was? Environmental, whatever, you know, he'd be the person, if that's your area of expertise, to say, hey, if you ever need anyone with my background, I'd be very interested and willing to serve on review panel or study section. Center for Scientific Review at NIH is the organization that convenes the study sections at NIH. They've got a video and stuff as to how the review process works. They post the rosters of the study sections that have met for the last 12 months. You can do a whole lot of homework and strategic planning on who the probable reviewers are. It is considered unethical to ever reach out and contact a reviewer, but it is absolutely appropriate that information is up there so you can get a really good sense of who's going to be grading your paper and make sure you can kind of anticipate what their concerns and issues are to address in your proposal, okay? So the NIH reviewers, and there's the review criteria that I mentioned to you previously: significance, investigators, innovation, approach, environment, ultimately leading to impact through commercialization, and we've got not just significant science, but significant commercial opportunity as well. And then NIH has reporter, very robust. You can look for every SBIR that's been awarded to anybody in New York State. You can look for any SBIR that's been awarded to a particular company. You can look at any SBIR that has arthritis in it. You can think of a whole bunch of different ways to slice and dice the data, and there's our Get Connected. You can get connected to NIH, okay? NIH uses grants.gov. Grants.gov launched in 2005. My hair was a lot darker then. I had a couple of years of real hate for grants.gov. We know grants.gov quite intimately at BBC. Chris in my office is our real magician. She knows the government accounting grants management, and she knows SAM, CCR, grants.gov, forms, electronic submission, registrations. Grants.gov, albeit extremely challenging to use, and one of the best pieces of advice you got today was get registered now and make sure you understand how these electronic submission systems work. And grants.gov is where Department of Energy, Department of Agriculture, NIH, that's where you're going to submit proposals. But it's a system where if you can overcome your own tendency to wait until the last minute, it will help make sure that you submit a good proposal by catching errors, okay? So you're going to have to get registered at grants.gov, and then you're also going to have to get registered in NIH accounts. So registrations at NIH are quite complex. So a number of you asked me earlier at the break about additional training, and we run a number of training courses. The bad news is for NIH, given my druthers, it's a 2-day course. It takes that long to walk you through everything from strategy to tactics of putting together a proposal to how to get registered and go through the electronic submission system to how to write a commercialization plan. So, but note that for those of you doing August at NIH, who else? Who else do I have? Thank you. August at NIH, you've got to leave. Do you guys all have EIN numbers? Bank accounts? Yeah. You gotta make sure you do that. You gotta get SAM going right away, and then you're gonna have to get grants.gov and NIH accountants registrations going right away. Okay? And that's what some of that information is. And then NIH has a newsletter. You can get connected with NIH. Are you starting to see the similarities and differences? Same information packaged differently. The last agency that I'll go through fairly quickly is the Department of Energy. I know there were some of you in here and you got a pretty good overview from the gentleman from Brookhaven. Department of Energy has been an interesting agency, and in the last 3 or 4 years, I think they've had a bit of an identity crisis because they're a granting agency. So they are an investigator-initiated granting agency. You got a lot of really good information if you paid attention when it was being presented about the fact that they're not just energy. That the Department of Energy's portfolio of funding goes well beyond energy into some basic sciences, the nuclear stuff. So there's a lot of stuff that Department of Energy funds. They are, as a granting agency, they go through grants.gov, it's investigator initiated, but they take a lot of time to target and narrow the scope of what they fund. So when I say they're a little bit of an identity crisis, they kind of feel sometimes like a contracting agency, but they're a granting agency. And so you have to be plugged into how they're thinking and what they're doing. Their phase 1s are 9 months. Not 6 months, not 12 months, they're 9 months, they are $150,000, and then their phase 2s are 2 years and $1 million. And every piece of data that I give you like this has always got the caveat of read the next solicitation that comes out because it could change, okay? I just pulled this off their website. This shows you what their schedule is for this coming fiscal year. They're going to have 2 releases, as the gentleman from Brookhaven mentioned earlier. One release will be focused on their basic science topics. And you're not going to get basic science funded by SBIR, it's product development, but it's going to be based in those areas where DOE funds basic science. And then the other one is going to be their energy and renewable energy topic. One's going to come out in July, the other in October. They'll have a number of webinars to help you describe the topics. The full FOA stands for Funding Opportunity Announcement. The full FOA will be released about a month after the topics are released. Here's something that DOE does that none of the other agencies currently do. They require a letter of intent. And the letter of intent is not optional, it's required. It is not, I don't know, for lack of a better word, reviewed. It's not reviewed and you are not invited to participate or not. You must submit a letter of intent. Anyone who submits a letter of intent can submit a proposal. They use it to help plan how many proposals they're going to need to review so that they can recruit appropriate reviewers, okay? So make note, they're the only agency currently that's requiring, that I'm aware of, that's requiring a letter of intent. Then your application will be due in October for the first release, February for the second release, and they're fairly quick at making decisions. Here's phase 1 and phase 2 solicitation will work relative to when your application is due, what happens before when the FOA is released, and then what their timing is for negotiations and making awards, okay? And then they'll have they narrow their topics a fair bit at Department of Energy. So you have to be careful. Over the years, we've had, 1 year there's wind turbines and the next year there's no wind turbines. So you gotta be careful to see what they're coming out with, okay? Another thing that they're doing, a couple of agencies are doing this, is having different budgets based on specific topic areas. I think it's Department of Energy that's come up with what they're calling tech transfer topics. So they have their general topics, which have $150,000 phase 1, $1 million phase 2s, and then they have select topics that are based on technologies developed internal to Department of Energy labs that they want small businesses to help license and transfer out of those labs. So they are putting those out in what they call tech transfer topics. Only one award will be made for topic because then you will get an option to an exclusive license to that technology predicated on your pursuing development of the technology. and the budgets are higher. It's 225 for a phase 1 and $1.5 million for a phase 2, I think, for those tech transfer topics. So there are some interesting things coming out from some of the agencies, and that's one of them the Department of Energy has started doing. They've got a database of funded projects, and there's the outline on their letter of intent for their 2 releases. And then their criteria are similar to the other: scientific and technical approach, your ability to carry out the project, and the impact it will have. So once again, the quality of the science, the quality of the commercial opportunity and your ability to pursue it, and the qualifications of your team and your resources, just packaged in some different words, okay? And then their review panels are made up of a combination of university, industry, and Department of Energy lab personnel. And then there's some slides here on what goes into their summary. And then here's what their 15-page narrative looks like. And if you look at this and you can think about this, it's a little bit of a hybrid between the NSF and the DoD. So you have technical objectives, work plan, performance schedule. That all sounds kind of DoD-like, okay? But you've also got information on your principal investigator, other key personnel, facilities and equipment, and there's always a budget, okay? So again, same information, packaged just a little differently. They'll ask for a commercialization plan, and the commercialization plan has the information that we discussed previously. I needed a better translation slide. NSF, DoD, NIH, DOE. You see similarities and differences? 3 granting agencies, 1 contracting agency as an example. Any specific questions about the process? What do you want to do? Why do you want to do it? Can you back it up with references from the literature? Have you assembled a qualified team? Have you found appropriate consultants and subcontractors? Have you started to map out a budget? All of the strategic planning is what's going to help you sit down and actually write those sections. Yes, sir?
So I'm a biochemist, but I have a project for energy. If I were to make a prototype that is not anywhere close to being a done product, but proves simply that the concept would work as a preliminary data piece, would that then be sufficient evidence that I would be able to execute that project?
Oh, that's a tough question. I doubt it. My short answer would be, I doubt it, okay? So qualifications, you've got 2 levels of qualifications, principal investigator and the team. And those go in context with each other. A weaker principal investigator surrounded by a strong team is sometimes better than an amazing PI with nobody else but themselves. So we look at the team and we look at the PI and we kind of collectively say, does this team have the ability to deliver? And does this principal investigator have the necessary and requisite expertise to also manage the overall project? How do we know if people are qualified? Where in the proposal? Well, there's a couple of different places. One is in biographical sketches, and that's one place you'd have a problem if you're a biochemist developing an energy project. Number 2 is in the preliminary data and who and how it was developed. Preliminary data, by definition, is data that you and your team acquired as opposed to data from the literature, which is background significance or other. So preliminary data helps demonstrate the qualifications of the team or whoever developed it. The third way, indirectly, that we assess qualifications of the team is how well you've described the field and your knowledge of it, okay? I don't think, and I'm giving you a very general answer based on my opinion, that in the presence of extremely compelling preliminary data and a very comprehensive knowledge of the field will override somebody with no prior energy experience as a PI. I don't think that'll cut it, okay? I could keep going on, but so you might want to be a member of the team, but you might want to find somebody else to be PI, okay? That's my gut opinion reaction. Okay, just a few things on commercialization, and I'm going to be right on schedule, okay? I've got just a few things to tie things together. How are you successful with a compelling project that's got innovation and commercial potential, with an eligible company, a qualified PI, an exceptionally strong team, and very suitable and appropriate facilities to do the work? I cannot possibly know much about anything about the majority of technologies that you all are developing. I don't think me and my team need to help you put together really the proposals, because there is no grantsmanship that will turn a bad idea into a good one, but there are many ways to disguise a good one. And that's kind of what Matt was saying in a little way, and part of what he was doing. It's as much about how you present the information and provide the rationale and justification. You have to read the solicitation. You know how many, this proposal this would meet the requirements of most solicitations as far as font and margin and things like that. And you have no idea what reviewers get. If any of you are ever reviewers, you would have a completely new appreciation for something as simple as structure and format of a proposal. Things like, here's the chart I'm going to give you, here's one of my hints. 2 worst words to ever put in a proposal. We believe. We believe that this will change the world. We believe that. I call those, by the way, the proselytizing proposal. You will never convert reviewers. So we is not the appropriate tense. It's not tense. I'm not a grammarian. Yeah. It's the company, the principal investigator, the consultant, the subcontractor, not we, because I don't know who we is when it comes to SBIRs. And belief has nothing to do with it. Of course you believe or you wouldn't be doing this. We want data, projection, assumption, expected outcome, but not belief. So be very careful how you develop your proposals and keep them very simple. Someone said 5th grade level. I subscribe to 8th grade Scientific American style writing, but you get the idea, okay? And deadlines, you have to meet the deadlines. And the single worst enemy you've got is last minute. It happens consistently. I had an email last night. I got into town last night around 8 o'clock, checked in the hotel. I had an email from a guy in another state who one of the state economic developers said, call BBC, they'll help you. He's putting in an NSF proposal. It's already written. Just give me some quick pointers in review, and it's due in 3 weeks. And I'm going, oh, we're going to, last minute. He just put it together. Can you help me? No, where were you 2 months ago? Okay? There's a national conference, happens twice a year. You just missed the one in DC. The next one looks like it's going to happen in Missouri in December. I think I mentioned that earlier. For those of you specifically interested in NIH, NIH has its own national conference in addition to participating in the general ones. This year is an unusual one. It's usually in the summer. This year it's going to be in the end of October in Sioux Falls, South Dakota. Woo! So I hope some of you come because I'm going and I'm really hoping there's more than a couple of dozen people in Sioux Falls, South Dakota. But all of the agencies are trying to reach out to underserved states and take the mountain out to Muhammad or whatever it is. So we're going to go to South Dakota, and those of you with an NIH focus are well advised to think about coming to this particular conference. So with respect to commercialization plans, a few tips that I can leave you with. A good idea is necessary but not sufficient. Did we kind of explore that pretty well today, that it's not just about the idea? SBIR does not fund science fair projects. They certainly have. For many, many years, they've funded many, many science fair projects. Okay? It's all about commercialization now. You can't know everything. You have to have business as well as technical expertise. So we talked earlier about the fact that the majority, not all, but the majority of SBIRs start from the scientific side. Please take advantage of the resources. Gloria made a plea earlier for using your SBDC. You've got incubators. You've got other economic development resources as well. Take advantage of them early in the process to bring the business expertise together with the technical expertise. I said this earlier. I will stand by it. A market analysis is a necessary component of a viable commercialization strategy or plan, but it is not a commercialization plan. So the proposal that goes in that says this is $1 billion market, and of course, you never tell me what $1 billion of what. It's just $1 billion. The market for high throughput screening is $1 billion. $1 billion of what? And then, oh, by the way, we're going to have 10% market share in year 3. That's your commercialization strategy. SBIR sees that all the time. You want to differentiate yourself? Have a credible commercialization strategy that's based on a sound market analysis, and don't confuse the two. There is no such thing as the build it and they will come business model, which is what I just described. And another way to look at it is you cannot have a black box. Technology in and money out. That, by the way, is commercialization. Technology in, money out. But how? Open up the black box and tell me. The engineering he says, open it up. Tell me the mechanism by which technology goes in and money comes out. And that's your commercialization strategy. Ability to provide a solution to a problem in exchange for money. For every SBIR unsuccessfully that has the attitude that let me demonstrate the science first, Because why should I bother dealing with commercialization if the technology won't work? I tell you, why should I bother to fund your technology if there's not at least, and I like the word credible, a credible commercialization strategy. It will change. One of the best things you can do, go back and ask some of your presenters today. The products you're on the market with right now, are those the products 8 years ago you thought you'd be marketing? And chances are, well, no, not exactly, right? So where you start and where you end up are not always the same thing. But a credible commercialization strategy is going to be what you need to start to gather the other resources you need to use SBIR as a component of a funding strategy. And if you do that, it's going to be a really, really great source of capital, and you might actually make it all the way to market. And with that, how did I do that? It's 4 o'clock. How did I do that?